In this example, we're going to find the area of the region in the first quadrant that is bounded above by this square root function, y equals the square root of x, and below by both the x-axis and the linear function. So we really need to pay attention to what our boundaries are and what is above and what is below. So let's look at the graph first. That's always what we should do. Create a graph. And remember, we are focused in the first quadrant for this problem. So we want to find the area of this region. Remember, or note here, that we are specified that we're in the first quadrant. So what does that mean? That means we also have this boundary that we don't really see on our graph, but we need to note. In the equation of that boundary, that would be the line y equals 0. So I have this green function here. This is my linear function. That represents y equals x minus 2. And this red curve, that's my square root function. That represents y equals the square root of x. So the area of this region, we are looking at this sort of curved triangular space. So now I implore you to think here, what function is above and what function is below? And do we have the same function as the upper or lower bound for the entire problem? And the answer is no. You see, if I divide this right here, if I draw this little invisible line, you'll notice that from 0 to 2, my upper bound is the red square root function, and my lower bound is that horizontal line, y equals 0. But from 2 to 4, my upper bound is the square root function, and my lower bound is the green function, y equals x minus 2. All right, so if we were thinking about how to set this integral up, we would need to break it into two pieces. The area is going to equal the integral from 0 to 2 of square root of x minus 0 dx plus the integral from 2 to 4 of my upper function is square root of x minus my lower function is x minus 2. So take a moment, pause the video, make sure you understand how I've set this up, because the setup is really important. And so just to re-emphasize, this first integral, that represents the area of a region we might call A, and the second integral represents the area of this region B. All right? So now that we've set it up and we understand how to organize it, we just need to solve our integrals. So we're going to solve area A and then area B. So that first integral could be simplified 0 to 2. Square root of x minus 0 is still square root of x, and I'm going to write square root of x as x to the 1/2 power, to the positive 1/2 power. Plus, I would have the integral from 2 to 4. Again, I'm going to take x and write that as x to the 1/2 power. I would have minus x, and then because we distribute, I would get plus 2. So each of these separate regions here, integrating them, this first one, integrating x to the 1/2, add 1, that's going to be x to the 3/2, divide by 3/2, that's going to put a 2/3 out front. we need to evaluate that from 2 to 0 plus, again, we'll get that same term, 2/3 x to the 3/2. We'll get minus x squared over 2 plus 2x, and that would be evaluated from 4 to 2. So for the first piece, if I plug in 2, I'm going to get a value. Plugging in 0, that's just going to give me 0. So I'm going to get 2/3 2 to the 3/2 minus 2/3 0 to the 3/2. And 0 to the 3/2 is 0, times 2/3 is 0. We don't need that piece there. So this first piece, if I cube 2, that gives me 8. So I've got 2 square root of 8 over 3, which square root of 8 is 2 root 2. So I have 4 root 2 over 3 for that first term. So now we need to deal with this second integral. First, I'm going to plug in 4. So I have 2/3 4 to the 3/2 minus 4 squared over 2 plus 2 times 4. And we are going to subtract from that all of what we get when we plug in that second bound 2. So that would be 2/3 2 to the 3/2 minus 2 squared over 2 plus 2 times 2. So what do we get for our terms here? I have 4, the square root of 4 is 2, cube it, that's 8. 8 times 2, I've got 16 over 3. Minus 16 over 2 is 8. Plus 2 times 4 is 8. Minus, this first term I get here is again 4 root 2 over 3. Minus 4 over 2 is 2. Plus 4. And if we look at distributing that minus, we can get rid of some parentheses in here. And so I distributed, and these purple parentheses now are purely associative. So let's look at what cancels. 4 root 2 over 3 minus 4 root 2 over 3. 8, negative 8 plus 8. So I've got 16/3, and this value is minus 2. So 16/3 minus 6/3, my answer here is 10/3. And so that's the area between two curves, but we had to pay attention in this situation because the upper or lower bounds changed. In this case, we had two different lower bounds, so we had to separate the integral into two pieces.